and welcome to my video, System Administration, an Introduction to Linux. My name is Stacy Morganroth-Lapham, and I'm the instructor for Schroeder High School. This video is meant to be an introduction to Linux, so we're going to try to give you a bit of an overview of the concepts that you have to understand before you actually start using Linux. We're going to talk about what Linux is, where Linux came from, and all of the fundamental concepts that you have to understand before you start building your own Linux servers and maintaining your Linux systems. Linux is not a program like a word processor is. It's a kernel. Well, what does that mean? Let's take a short summary look at what a kernel is, why it's important, and where it came from. Every multitasking computer uses a kernel. So what is it? Well, basically, a kernel manages the CPU resources, the memory resources, and processes on any computer. It also has a device driver in it, in case you want to do any networking. It's considered the lowest layer below the CPU. Kernels can be complicated, though, since they do so much essential work. And there are two basic kernel designs: monolithic and microkernel. Well, what's the difference between monolithic and microkernel? Well, a monolithic kernel, like Linux, means that all the services, all the devices, all the stuff handling memory are all found within one program that occupies one memory space. So, in summary, the kernel is really the lowest level of any operating system. It's responsible for the CPU resources, the file resources, the drivers, and networking. It really is the lowest piece of software that comes before the hardware. Linux is an open source kernel that has available customization depending on the needs and uses of the user. One of the reasons for Linux's popularity is due to its distributions or its distros. So let's take a look at just a few of the more common, more popular distributions that Linux has to offer. The first is the Ubuntu server. And Ubuntu is an open source operating system that runs from the desktop to the cloud to all your internet connected things. It's so popular because it works with nearly any hardware or virtualization platform. The second is the Red Hat Enterprise Linux. Red Hat Enterprise Linux is a Linux distribution that was developed by Red Hat and targeted towards the commercial market. It can work on desktops, on servers, in hypervisors, in or on the cloud. The third is CentOS. If you operate a website through a web hosting company, there's a very good chance your web server is powered by the CentOS Linux. This low-cost clone of Red Hat Enterprise Linux isn't strictly commercial though, but since it's based on the Red Hat Enterprise Linux, you can leverage commercial support for it. And the fourth, ClearOS. It's an open source Linux operating system based, once again, on the Red Hat Enterprise Linux and on CentOS. It combines a server, network, and gateway platform. By no means is this the extensive list of distributions available on Linux. These are just four of the more popular distros that are currently being used and supported. Now that we have a cursory summary of what Linux is, let's take a look at how Linux came to be, as well as how Linux was shaped to what we know and recognize it is today. It all starts with Linus Torvalds, who created a free operating system in the August of 1991. But here's the thing. He actually intended it to be just a hobby. He had no intention that Linux would become a large professional operating system. We know that's not true today. We know that due to many years and many people, Linux has really taken off as one of the popular operating systems in today's technological world. Just a year later, Linux had its first GPL, which means that it had a free software license, guaranteeing end users the freedom to run, study, share, and modify the software. The license was originally written by a man named Richard Stallman of the Free Software Foundation, or the FSF, for the GNU project, and it grants the recipient of a computer program the rights of the free software definition. GPL was the first copyleft license for general use. Over the next 9 years, from 1992 to 2001, Linux continued to grow from a hobby to a more professional operating system. As each year progressed, Linux saw an increase in developers and interest around the world. In fact, by 2001, IBM pledged to spend $1 billion on Linux. In the same year, the 2.4 was released, which added a bunch of new technology such as Bluetooth and USB. And this was also a huge year for the commercialization of Linux. 2002, Linux moved to source control management. And in 2003, the SCO group filed suit against IBM, which added a lot of uncertainty into the Linux ecosystem. In 2003, Linux was the heart of a technological debate turned into a legal battle: open source software versus intellectual property. Technological company SCO sued technological giant IBM for $3 billion, claiming IBM broke a contract and misused trade secrets. SCO claimed ownership of Unix, an operating system used to run all sizes of businesses. They claimed that IBM took their Unix code and placed it into the free source Linux system. SCO also claimed that it could not compete with a system that was free source, easy to modify, and which they say was run with their own created trade secrets. Linux users argued that they had not seen proof of copied code or evidence that the IBM product was a deviation of Unix. The SCO versus IBM case was kept alive in court systems for over 13 years through the appeal process. Basically, the users of free software Linux should be held accountable to SCO for the use of software developed by their company. This software was used by many companies such as Novell, AT&T, IBM, only to name a few. Many of these third-party companies and other individuals have adapted and modified code. But this case brings up many questions, such as who was right, who was to blame, what did this mean for the future of open source software design, usage, and distribution? The end result? We still don't know. The original SCO, also known as Santa Clara operation, that created the SCO flavor of Unix sold their IP to Caldera, who later renamed itself the SCO Group. The SCO Group originally tried to say that every Linux OS owed them royalties, but Novell sued them and won regarding their point, and then identified Linux users so that avenue is totally dead for SCO to generate revenue through litigation. Regarding their most recent appeal, their case appears weak. The original SCO sold the bulk of the operating system rights to Novell and licensed what they had with IBM, which in reality is not a patent violation, but actually a license violation, which means it could not be applied to anyone else who used the open source code in their kernels. Despite these continued appeals and litigations, Linux stayed strong, building their user base. Let's continue on with our study of Linux progression throughout the years. 2004, we see the commercialization of Linux really becoming more relevant. The Linux team started to release new kernels on a regularly scheduled event. 2016 saw the first long-term support or LTS release. In 2016 marked the final resolution in the SCO case, which was started back in 2003. There are currently over 135,000 developers for more than 1,300 companies that have contributed to the Linux kernel since 2005. Linux is everywhere, with over 22 million lines of written and developed code. As is the case with any operating system, users need to compare the pros and cons before devoting themselves. Let's take a hard look at some basic pros and cons to the usage of Linux's open source operating system. Let's start with some strong arguments for the pros of using Linux. Linux is considered secure and private. Unlike Windows, Linux has no tracking by its system. Linux has options in workflow for the user. The user has the ability to change and customize their workflow style. You have many options based on your needs. Third, the software is considered better than ever. Lately, other softwares are being pushed out as new versions, but with a subscription-based model for Windows. Linux software is becoming more and more of a competitor in the software field without subscription models. Fourth, choice in appearance. Appearance does not always matter, but can modify and dictate workflow for the user. The workflow can help drive a more successful work environment. And the fifth pro for using Linux over Windows or any other operating system is that Linux is mostly free and it's open source. Most of the software packages can be found in a free, open sourced environment. Not all, but most. You can also audit those programs, monitor them, and adapt them as needed. So with all of these good pros, why wouldn't we always use Linux? Well, like anything else, there's always going to be some cons. So let's take a look. The first con is that some people consider some of the distributions of Linux not very user-friendly. Many have no graphical user interface, so in order to use them well, you have to know the commands. A second con would be that Linux is not primarily a gaming platform. Today, a lot of people use their computers for gaming platforms, and Linux just isn't up to snuff yet. Many games don't function on Linux. And a third con is that it's not really easy to find the support that you need or to find an answer in Linux. It's really easy to mess things up, and some of the error messages can be kind of cryptic. If you don't know the answer, you might have to do extensive searching to find the solution to the problem instead of a more quick and easy software support. So what are some of the fundamental differences between Windows and Linux? Well, first, Linux is yours. Windows is still theirs. Well, what does that mean? This is basically the difference between proprietary software and open source software. The user leases Microsoft software, so they don't own it, and in fact, any changing or modifying it can lead to criminal charges. Microsoft can change anything to their software on your system without any repercussion by you. Linux users, however, have full administration to do what is installed, changed, modified on their own system. Redistribution of free and open source software is actually encouraged. You have full access to every part of the system. If you have the knowledge, you can change everything in the system to meet your needs. Second difference between Linux and Windows is that Linux desktops do not need any antivirus software, where Windows is still extremely vulnerable even if you have an antivirus installed. Now, it's not simply a matter of Linux having less users that make it more secure. The system is just inherently secure. While no operating systems are totally secure, the chances of Linux getting a virus are very, very small. In fact, 3/4 of the internet runs on Linux. Windows users are encouraged to install and pay for antivirus software that's only about 20% effective. And the reason is because of the backdoor policy that Microsoft has. Why the backdoor policy? Because once again, it is a leased software. So Microsoft can get into your system anytime they want. That backdoor policy leads to potential problems with security. Also, antivirus softwares severely limit system performance. Linux security depends on stringent observance of user privileges and file permissions along with keeping the system up to date with the latest security patches. Linux uses a centralized software approach, Windows does not. Most Linux software is available from distribution-specific online repositories. Users have access to thousands of free programs that can be installed from graphic software managers or simply commands at a terminal. In addition to distribution repositories, users can download software from third-party package management systems. Some software is distributed for direct download in package formats. Most new user-friendly Linux distributions come with the most needed software already installed. Linux software is installed in predetermined directories. It cannot be moved or installed elsewhere. Windows, on the other hand, has a quote-unquote store, but most users still think of downloading software from independent websites, some of which can contain malicious code. In Windows, you have the concept of being able to tell the system where to install software because it generally has one executable file whose directory can be modified or changed. Linux has built-in hardware support. Windows requires users to find and install drivers. Hardware with Linux support usually just works without the need for users to do anything. Proprietary drivers are available through online repository for hardware that requires them. Many distributions automatically install them during setup or make them available to users through special graphic driver manager applications. Many Windows-based driver packages include unwanted software or hardware. Usually, when you install Linux on a system, it either works or it doesn't. Some things have proprietary drivers with them, and usually your distribution will generally install them automatically. Number 5. Linux updates everything at once. Windows does not. Most Linux systems look for updates automatically and alert the user when they are available. Windows generally only updates Windows and some select Microsoft software. Windows is notorious for downloading and installing updates and then restarting the machine without users' consent. Linux does not require programs to run in the background looking for updates, which a lot of Windows programs do, slowing down the system. Unlike Windows, Linux will never restart the computer without your permission. And the last thing we're going to talk about is a technical system thing. Linux uses /dev for drives where Windows uses its ABCs. So what does this mean? In Linux, the way it works is that drives are represented in the dev directory. Linux treats all storage devices and network storage as a directory, so any hard drive or network storage can be mounted somewhere within the file system. Windows still uses a DOS-like model where each drive is assigned an arbitrary letter to identify storage needs and network connections. So basically, if you hook something up to a Windows system, it just becomes a letter. Then you can point to it and reassign it to the file manager, which works for a small system, but not on a scalable system. So here are 6 basic differences between Windows and Linux. It's now up to you, the user, to decide what's best for you.